Hello everyone! Today I'd like to show you how I nickel plated and tested this electrode for my hydrogen generator. Okay, so I started by making a tank out of glass so I could film what was going on inside. I also made the tank quite narrow to minimize the amount of nickel acetate I needed. Okay, so the first test electrode will be made from this copper plate, which is just a copy of this stainless steel plate that I used before. And I will use this as a template. Well, actually this one. This is just a neutral plate, and what I did is I glued a piece of plywood underneath just to get some clearance, because if I would just use a normal plate as a template, then the shaft of the drill wouldn't be through the template before it hit the copper plate, and then it would wobble around and would be less accurate. So with this template, with the plywood underneath, you get a bit of clearance from the template to the copper plate. So this way the drill is completely through the template before it hits the copper plate. You have more accuracy. So let's drill the holes. Okay, so the tank is now all filled up with vinegar or acetic acid, and now I have this device which I also used in the previous experiment, and I have this piece of pure nickel strip. It's absolutely important that you use pure nickel strip. This just fits in here, and it just stands here at the bottom, and well, of course it will dissolve some of it away, and then it lowers itself, so you have a constant feed of nickel into the solution, which I need to make nickel acetate. So we'll put this in here. So it's now only a small amount of nickel is inside the solution, so only that part will dissolve. And then I put another piece of nickel strip in here. Just clamp that to the side. Like so. Put the negative on this side. And positive on this side. With a piece of duct tape. Okay, this is ugly. I don't like this. It's not good for nice shots. And of course it needs some salt for better conductivity. So this is now all in place. Now I just need to add the fume extractor. It's very important that you have good ventilation. I have my blower here. And I specially installed this for this experiment. and also for welding, because it's all not nice to inhale all that stuff. So I'm glad that I have that now. And from the nickel plating and also making the nickel acetate, there's a little bit of hydrogen coming off. It's always nice to just have outside of your shed, and there are coming some fumes off of it with maybe some nickel in it, so best not to inhale it. So now if I apply voltage, nothing happens. Oh, now it's running 150 milliamps. Yeah, hydrogen is forming here. So the nickel is dissolving. So now we just wait, and I think we'll make a nice time lapse of it. Okay, so it's now been running for about 20 hours, and I think the solution is now more or less completely saturated, and I put this cling film over it so it wouldn't evaporate too much. And you can see that this is the anode I used for making the nickel acetate, that there's quite a lot of nickel deposited on it, so which is good, because that means that I now can start nickel plating. And what I first want to test is, I want to nickel plate this copper plate in one sitting, and then I want to know if when I start plating this copper plate, if I can just put an anode here, if it will nickel plate it evenly on the surface of this plate, or that I have to have a similar surface area in front of this plate to completely nickel plate this copper plate evenly. So I'm going to test that with a copper strip of about 1 centimeter wide, and that strip will be nickel plated. The negative terminal will be attached at this end of the copper strip, and the anode will also be at this side in the nickel acetate. This way the resistance through the nickel acetate will be much higher from the anode to this point than it will be to this point. So my assumption is that the nickel plating at this end of the copper strip will go slower than at this end, because it's closer to the anode. Okay, so I now have a copper strip in here which will be nickel plated, and this is the nickel anode, which will dissolve into the nickel acetate to replace the nickel that will be deposited onto the copper strip. So I will now slowly increase the voltage. I can see here that it starts bubbling a bit, and it's not bubbling over here, which already points in the direction that the nickel plating will go faster at this point. So we'll now let it run a couple of hours, and then we will see how it looks. Okay, so this is the result. You can clearly see that the copper strip only has been plated near the anode. This tells me that I need an anode with a surface area as large as the part that I want to nickel plate, and I have a solution for that. Here I'm making a sort of pouch out of Kimberly & Clark cleaning cloth to stick nickel strips into to form a large anode. This cloth is made out of pure polypropylene, and I'm welding the cloth together with my constant heat roller and a piece of baking paper. But you can also use the side of a flattening iron to weld the cloth together. Okay, so this is now finished. Now we need to clean this copper electrode. I'm going to brush it with a wire brush so it becomes absolutely clean, and then I'm gonna wipe it off with some hydrochloric acid and then clean it off with some demineralized water so it won't contaminate my solution here. And then it's time to start electroplating. So let's do that. Okay, so we're now ready to start plating. The nickel strips are on this side, which is going to be the positive side, and the copper plate is on this side, to which the nickel will be deposited. So let's apply some voltage and see what it does. Nice even spread of bubbles. You can see here that there are bubbles all over the surface, which is very nice. So we'll now let it run for a couple of hours and we'll see how it goes. So after plating for several hours and swapping it around a couple of times to get both sides plated, this was the result. And you can see there were a lot of spots where the nickel didn't stick to the copper at all. This was because I didn't clean the copper plate well enough, and because I was plating one side at a time, the other side that wasn't plating oxidized a little in the nickel acetate solution. So now I finally knew what to do to properly nickel plate this electrode. I tried sanding off the nickel, but that didn't work, so I used the wire brush again and completely cleaned off all the nickel on one side, and on the other I only brushed off the loose bits, just to see how that would replate. So I then properly cleaned the plate with hydrochloric acid, then rinsed it off with demineralized water, and immediately started plating to prevent the formation of a new oxide layer. As you can see here, I now plated both sides at the same time, and I made sure that all the nickel strips were making good contact with the copper strip, because previously some were less eroded than others. So then I applied 1 amp and let this setup plate uninterrupted for 7.5 hours. And this is the result. As you can see, both sides now have a nice even coat, so this electrode is ready for testing. Okay, so while testing the new electrode, I'm also going to test the new membrane. I will use the same Kimberly & Clark cleaning cloth for it, because it's made out of pure polypropylene, which is very chemically resistant and therefore seems to be a good candidate. I'm going to glue the membrane in between two seals to minimize the chance of leakage. I will seal it with my favorite caulking, which is also very chemically resistant. So this piece of polycarbonate is one of the outside pieces, and normally the whole stack was clamped together with threaded rods and nuts, but it's a lot of work to assemble and disassemble the generator that way. So this time I glued in these pieces of Delrin, so I can just slide all the seals, membranes and electrodes over them and then clamp the whole stack together with these stainless steel frames. There were still some leaks because the frame was clamping more at the corners than in the middle, so I solved it with some duct tape to make the frame clamp more in the middle. I also sealed off the holes on the other polycarbonate plate, and I put some extra sealant on the outside because there was still a leak in between the membrane seal. So then it was perfectly sealed and ready for assembly and testing. So as you can see, it runs perfectly and the separation also works well. So I made a small hydrogen balloon. I also did a bubble test to see how pure the hydrogen was, and it seems quite pure. In this clip you can clearly see the nickel layer oxidizing a bit, which is not a problem because the nickel oxide does not dissolve in an alkaline solution like sodium hydroxide, so it stays attached to the nickel metal. And when the generator is turned off, you can see that the blackness goes away, and I believe that's because the nickel oxide is catalyzed back to being metallic nickel. Okay, so it has now been running for about 65 hours. So we'll now open up the hydrogen generator to see what it looks like inside. Okay, so the generator is now open, and the nickel electrode looks quite well. This is the side we could see, and this is the side that sustained the most wear. Well, you can see there's no copper visible, there's no visible erosion or whatsoever. So I have quite a good feeling about this. The stainless steel plate that I used has some goop on it. I'm not sure what it is. I don't think this can be a chromium oxide because this is the cathode side which only generates hydrogen. I later realized that it's probably iron and chromium oxide, which was the result of galvanic corrosion because iron and chromium are lower in the galvanic series than nickel is. This galvanic corrosion probably happened because when I turned off the power supply, I left the generator connected to it, and because the power supply apparently has a 100 ohm resistance between the positive and the negative output terminal, some current could run through it, and therefore the circuit was completed, and the generator became sort of a battery. I disposed of the oxides by wiping it off and putting it away as chemical waste. In the end, all of this won't be an issue in the new generator because I'm only going to use nickel-plated copper electrodes, but I'm going to do some small-scale tests to see if my galvanic corrosion hypothesis is correct. So because this works well now, I'm going to make more of these nickel-plated electrodes to make a whole stack like the generator was, maybe 2 plates extra to make it a little bit extra efficient. And the membrane also looks quite well. It's a bit short to really say that it will hold up for a long time, but I don't see any spots where it's dissolved or anything, which happened with the previous membrane. So I'm going to use this as well in the hydrogen generator. And I also bought this oxygen detector, and I will include that in the system so I can always check if there's no oxygen mixed within the hydrogen. And I am going to use the alarm of this to trigger a system that shuts the whole thing down when that happens. But that's something for a later video. Okay, that's it for this video. I really wish I could make more of these videos, and I hope someday I can make this my full-time job. So to help me reach that goal, I started a Patreon account where you can support me to make more of these videos. And as a bonus, you will have your name in the end titles and you will have access to behind-the-scenes experiments. So for now I'll say thanks for watching, please like, share and subscribe, turn on the notification bell, and see you next time!